Hi everybody, Miss Lorenz here. I'm going to talk about the 8th grade sections 2.1 and 2.2. This has to do with solving equations, and I know that some of this is a review, so what I want you guys to do is do both these sections, 2.1 and 2.2, and then do a superset over those two. All right, so let's start by talking about what we mean by like terms. What we often have to do when we solve equations is start by combining like terms. So both of these terms in this equation, 1/3 x plus 1/6 x equals 36, we have this term is an x term and this term is an x term. So since they're both x terms, we're going to combine them. And so I have 1/3 of an x, which in my head I'm thinking, oh, well, that's 2/6. So I have 2/6x plus 1/6x, and I'm left with 3/6x equals 36. Before I simplify this any further, I'm going to remember that after we combine like terms, we want to isolate. We want to isolate the variable. And remember, the word isolate means be by itself. So we want to get that variable, the x, by itself. So in order to do that, here 3/6 is being multiplied by the variable. So to essentially get rid of it, I want to do the opposite operation. So since we're multiplying by x, the opposite operation would be to divide by x. But remember, dividing by a fraction is the same as multiplying by the reciprocal. So when I divide by 3/6, I'm really multiplying by 6/3. And when I do this to my left side of the equation, I have to do it to the right side. So since I multiplied by 6/3 over here, I have to do the same over here. Remember, the only reason I'm multiplying by 6/3 is because multiplying by 6/3 is the same as dividing by 3/6. So when I do that, I am left over here with just an x because my 6's cancel and my 3's cancel. And then over here, I can cancel out some factors. I know 3 goes into 3 once and 3 goes into 36 12 times. So I'm just left with 12 times 6 is 72, and 1 times 1 is 1, which of course is 72. All right, a couple things to remember when you're combining like terms. If there is not a visible coefficient of your variable, don't forget that that coefficient is 1. So here we have p minus 35/100ths of a p. You're still going to combine those like terms because that's a 1 minus 35/100ths. And 1 whole minus 35/100ths is 65/100ths. And that's where I get this 65/100ths p equals 130. Now, remember, the number sitting next to the variable means multiplication. So to undo it, we're going to divide. So here we're going to divide by 65/100ths. And we have to do that on both sides. When we do it on the left side, the 65/100ths essentially cancels each other out, right? Because any number divided by itself is 1. So we're left with just 1p equals, and then I can divide 130 by 65/100ths, and I get that p is equal to 200. In this example, same thing, but you have to really be mindful of your symbols. So here, your negative sign, you have to carry that with you. You can't just drop it and ignore it. You have to think of this as negative 3.5 minus 6 2/10. And since we're subtracting a positive, we go further down on the negative side. So we're at negative 9.7y equals negative 87.3. So we're going to divide. Notice here, we're dividing by negative 9.7. So I want to totally get rid of the number being multiplied by the y. So I'm going to divide by that number, whatever it is. And so negative 9.7 divided by negative 9.7 is just 1, or 1y. But then I have to divide by negative 9.7 on the other side. Luckily, I remember that a negative divided by a negative is a positive, and when I divide this out, I'm left with just 9. A couple more examples. Here we're going to combine like terms because 0.8n and 0.6n both have an n. So we're going to add those coefficients, and we get 1 and 4/10, and those are 1 and 4/10 n equals 42. Because we're multiplying by the variable, to get rid of it or isolate that variable, we're going to divide by the coefficient. Since 1.4 divided by 1.4 is just 1n, we're left with just n, and 42 divided by 1.4 is 30. Okay, one last one. 3x plus 15 equals 4x plus 12. I want you to notice that each side cannot be combined on like terms. So in every one of these examples, we combined like terms on the same side of the equation. See, right here, same side of the equation. Here, same side of the equation. Here, same side of the equation. Here, there's nothing to combine on the left, and there's nothing to combine on the right. But we're still going to need to solve this equation. So I'm going to start, and there's different ways you could start. You could get rid of the 15 first, but remember, the goal is to isolate the variable. So I want to basically go through steps that will get me close to isolating the variable. So the first thing I'm going to do is I'm going to subtract 3x from this side of my equation. But if I subtract it over here, so now it's gone, right? But if I subtract it over here, I'm left with just 1x. So look what I have now. 15 equals x plus 12. I almost have this x isolated. So I'm going to subtract this 12. Now x is isolated over here, but then I have to subtract 12 on this side. And 15 minus 12 is 3, so I'm left with x equals 3, or 3 equals x. All right, that should be enough to get you guys going on the problems you need to do for 2.1 and 2.2, and then we'll do a superset after both of those sections. All right, thanks for listening.